All right, this video is again practicing the product and the quotient rule. This one's a product. I'm going to use the product rule for this, and it's on page 190, number 51. So this is part of your text assignment. And the question is on what interval is the function f of x equals x cubed e to the x increasing? Well, the first thing I did was actually graph it. So you see a graph here on the side, but it's a poor representation of what the calculator is. And I see that it looks like it's decreasing here, and then it looks like it's increasing from here to here, which is all nice to know. But we want to justify the graph and what's happening to it using calculus. So I come back to my poor little graph here, but let's talk about when I want to talk about when a function is increasing. If a function is increasing, what you're talking about is your first derivative. So I want to know that f prime of x is positive or greater than 0. Okay, I want to know when it's positive. Notice I didn't ask about concavity. I didn't ask anything about that. So that means we're not going to even have to worry about the second derivative. We're just going to do the first derivative. Okay, so on the side here, I want you to draw a graph. There's my representation. Set it all up with your f prime bar and get everything set up. So we're going to do the work over here to justify how our graph looks. Okay, so the first thing we're going to do is find f prime of x. Now I see this is a product. So this is going to be my f and my g. And I know the product rule is y prime is f prime g plus f g prime. And I'm just going to set up my f and g's. And plus that's fun to say. So my f is x cubed. My f prime is going to be 3x squared. My g is e to the x. And g prime is also e to the x because the derivative of a continuous exponential function is itself. Oops, squared, sorry. I just erased that to make it look better, and I wrote the wrong number there. Okay, so let's plug it into our formula. And it's an f, so we're going to do f prime of x is going to be f prime g. And you can write it just the way it is, or you can put the e to the x, but for the x squared doesn't matter, plus f g prime. So I'm going to write it as x cubed e to the x. Now, I know I'm going to have to put this equal to 0 and do this, but before we do that, I want you to actually practice everything looking in factored form because you'll find out this saves you a lot of work in the end. And I have a term here and I have a term here. So I'm looking at those terms. What do they have in common? Well, I see the e to the x I can take out and I can take an x squared. So I have an x squared and an e to the x I can factor out. What's left is just a 3 plus, and all I have left here is an x. Now I'm going to put this equal to 0 because this shows you the turning points or our critical points, which we'll learn later this year. Now, as we do this, I just want you to see is when we're putting this equal to 0, you're putting everything equal to 0, each piece. So I always tell everybody, draw a big T, when this is going to have 3 parts to it. So here's our big T. You're actually putting each part equal to 0. So I have x squared equals 0, x equals 0 when I take the square root of both sides. So there's one of my x's. I have e to the x equals 0, and guess what? That's never going to happen. So thanks for helping. I factored you out, but because it's an exponential function, it has an asymptote at y equals 0, so that will never be 0. So thank you for your help. Then I have 3 plus x equals 0, x equals -3. So now I'm going to go over here on my f prime bar, which is really a number line. I'm going to put the 0 here and the -3 over here. And I'm trying to match my graph a little bit. But as you can see, doesn't this have a 0 slope here and a 0 slope here? And that should make you happy because we put our first derivative equal to 0 to come up with those x values. So this makes me happy. All right. Now I want to check, and this is the one part I want to go through with you, is when it's increasing and decreasing. So you're going to look at, I'm going to use yellow to circle this, the factored form. And you're going to use this like a number line. We're going to try numbers to the left of -3, between -3 and 0, and over 1. So the left of -3 is a -4. If I put a -4 in here and square it, that's positive. A -4 in there, that's still positive because e to the -4 is positive. And if I put a -4 there, it's negative. So I know right here that my function is decreasing here. Okay. Now I'm going to try a number between -3 and 0. So I'm going to use -1. So if I put a -1 here, it's positive. A -1 here, it's positive. A -1 here, it's positive. So this shows right here that my function is increasing. So this shows that it's decreasing. This shows that it's increasing. Now I'm going to go to the right of 0 and use a 1. If I put a 1 in here, this is positive. Excuse me, in here, 1 squared is positive. A 1 here, it's positive. A 1 here, it's positive. So this still is positive, so my function is still increasing. And if I look at it, it does look like it's still increasing. It just kind of had a little pause there. So now it wants to know on what interval is my function increasing? Well, the interval, so your function is increasing on the interval of from -3 up, so it's going to be -3 all the way to positive infinity, and that's your answer. So that is number 51.